All right, guys. So I've graded a ton of homework. So take a look. If you feel like, well, you didn't grade a lot of homework, I don't have a lot graded, multiply yourself by 30 something. So graded a lot of homework. So let me know if you take a look at it, you have questions about why something's not quite right or something. Let me know. If you're missing a lot, if you're like, if I'm telling you to redo the homework, some of you guys get redo on your homework, you might want to try to get some time with me. Do the extra office hours or go see tutors. Or, I mean, yeah, you want to cash that right now because this class is dense with concepts. And I can only do so much with that. I need to get through enough so that people are ready for calculus after taking this course. So there's going to be a lot coming at you quickly. So if you have troubles right now, you've got to get that addressed now because things are going to build on that. So I do have a few notes from the homework that I want to kind of go over, some general notes. But does anyone have anything specific from the homework? Any questions? Or any other tapestries to show off? No? 3-7-15. All right. I like it. Straight and to the point. So this is number 15 in section 3-7. Oh, did I miss somebody? It doesn't sound familiar. Wait, somebody's private messaging me. Not that I remember, no. Let me see. So we're talking about this one right here? All right, I think so. So it's asking you, why would this problem, number 15, why would it not be 1-to-1? The way it's given to us, why is it not 1-to-1?
It's a parabola.
Yes, parabolic. I love it. Can somebody tell me where the mirror is for that parabola? What would this do to the standard parabola?
Go up.
Sorry? So here's a standard parabola, right? What would this do?
Down to 5.
Say again, sorry?
Down 5.
It would make it go down 5. All right, so here's the parabola, right? And this is not, it didn't really ask me to graph anything. So that's why my graph is rough, because this is just for me. Problems where you have to graph, I need to see scale, I need to see work. Okay. So what is making this not 1-to-1? Why is this not 1-to-1?
Doesn't pass the horizontal line test.
Beautiful. I love it. And we talked about this. There's basically one thing I could do, but there's 2 different ways to do it. So to force it to be 1-to-1, I can restrict the domain. This is what they mean by find a domain, restricted domain. So and right now the domain, what's the domain of this function right now?
-infinity to infinity.
Yeah, because I could use whatever number I want to for x, right? There's no restrictions on x at the moment. So this is interesting. We have domains that the function sets up. The function itself can tell me if there's a problem. Like up here, number 12, the domain is not going to be all real numbers because there is a value that will make the function undefined. But then I can further restrict the domain if I want to. So do you guys agree with me? If I chop off this part, would it become 1-to-1 now? Do you guys see that? If I chop that part off, that's the whole problem. It's got a part that kind of comes back over itself. It's like, well, if I kill it, but is that non-decreasing what's left? Now you start to see why they say this. Is that part non-decreasing that's left?
No.
No, this is totally decreasing. So I killed the wrong half of it, didn't I? Okay, now I've given away too much. Is that enough to get you guys started? Maybe? Okay. That's really all you have to think about. Did you have to graph it? No, as long as you realize zero. Zero is the key. The zero line here is the mirror, right? So this guy, where would the mirror be on this guy? Let's see if you guys understand this. Where would the mirror be on this guy? What happens to x plus 7? Where does it go?
Left 7.
Sorry?
Moves to the left 7.
Yeah, back 7. I don't know if I counted right there. So it'd be here. And so this would be, I want to cut the domain either from negative infinity up to negative 7 or from negative 7 up to infinity, right? I want to chop off one part or the other. Okay, I like it. So this one wasn't quite that freaky because it's centered at 0. So I want to cut it at 0, either cut this part off or that part off. I really want you guys to get that. It's that simple.
I actually had a question about 12, which is right above that. So if you get there.
All right, just a second.
Yeah.
I'm sorry. Is everybody cool with that? Is that enough? I basically gave the answer if you're paying attention. I gave the opposite of the answer, which means I gave the answer. All right, I'm going to clear this away.
Yes.
That's my favorite right there. That makes complete sense. All right, let me try again. I think I'm going to try. I got to try up on the chalkboard because this is just driving me crazy. All right, hold on. I'm going to clear this away. I'm going to clear all this away. Bye. Okay. Let me stop sharing. Let me turn off Mars. I love that I can say that now. And it makes sense. Mars. Go away. Okay. Sure. Other share. All right. Now. So if I have a parabola, in fact, let me make this even more interesting. So let me say that it's right here. I have the option, I could either, so right now it doesn't pass the horizontal line test, right? So if I get rid of this or this, if I just chop that piece off, the leftover will be 1-to-1. And it doesn't, it depends on the situation, which side you kill. In this specific problem, they say the leftover needs to be not decreasing. So another way to say that is increasing. Wow. So I'd have to chop off this part. So if I want, so right now that it's at 2. So if I chop this part off, now it's 1-to-1. And now the domain would be 2 to infinity. So that's how I would restrict the domain for my parabola. So now it would have an inverse. I like it.
Got it.
And here's a really cool thing I want you guys to realize. You all should know what the shape of a square root function is, right? What's the shape of a square root function? I have no idea how you can tell me. If I can. No, that's a parabola. What's the shape of a square root? There it is. Austin's got it going on. All right. So here's the square root. Doesn't that match up with a parabola where I've cut off the other side? Right? Cut it off. Bam. Now it's 1-to-1. Now it has that inverse. And there's that mirror that we talk about, right? For the inverse. Bam. That's why this is missing its bottom half, because I had to cut it. I had to chop it off. Weird math surgery that we had to do. So that's basically what this is. It's weird math surgery to force the function to meet the conditions for having an inverse. Okay, maybe. And we already know the square root function. We just are finally seeing the full story. All right. What's up? All right, cool. I like it. So the other question was number 12 on that same page. Oh yeah.
Yeah.
And we've done this before. Not exactly this, but we had to do this in the earlier section. So the minute you do the first step, hopefully maybe it looks familiar. What's the first step of finding an inverse? You do this. What's the first step?
Switch X and Y.
Switch X and Y. Now it should look like a problem we had earlier. No? We had a problem like this earlier. You had to solve for Y. So you're going to multiply it up, get your Y stuff together, blah, blah, blah. Do you remember that at all? Same steps. Just a different reason.
I followed it through. Once I got 5xy plus 4 is equal to 2y plus 3,
Sure.
I got a little wonky.
5xy plus 4x.
Yeah.
Now get rid of anything that does not have a y and bring everything that has a y, right? What's the fundamental idea of solving equations from algebra? Get everything on one side with the variable and everything that doesn't have the variable on the other side. Now, back in the day when things were simple, we could just say, get all the x's on one side, all the numbers on the other side. But now we know that was a specific condition. That was when you didn't have more than one variable. Go ahead.
I think I just struggle a little bit when it is like 5xy. Like I want to be able to steal the y away.
Of course. And you will. As soon as you move the other one, you can take a y out. You'll be able to GCF a y out.
Move the other y over to the other side with it.
Yeah, so you're at the step. You got this, right? Because you multiply this up. Switch these. You need everything with a y in it on one side. Everything without the y needs to be on the other side. And then you can GCF a y out. Then you realize there's only one y the whole time. This whole time, it's been inside me. That's why there's only one y. You can't see that until you got them all together. You can take that y out. You're like, holy shit, there's just one y. All right, maybe. I really need you guys to go with me on this whole journey we're in. There's a lot happening. And there's a lot of mistakes happening also. That's why you need to ask questions. You need to come to my office hours. You need to see a tutor. You need to be on it now because this class is dense with stuff. We're going to be doing a lot. Anything else you guys got? Any other questions from homework or anything? I have questions that I'm going to ask myself for you. Help me out, guys. All right. There is something I want to nip in the bud right now. Let me see if I can get this fully through to you guys, because this is what makes me cry when I teach calculus, when I have calculus students making this mistake. At this level, I'm not okay with it, but I can understand it a little bit better. Oh, I'll get to that. Well, let me do this one thing and then I'll get to that. Would you say that the square root of 25 equals 7? Is that true? This is not the thing yet. Don't worry.
No.
No. Okay, that's easy.
No.
But I'll have people do this. Isn't 25 9 plus 16? Isn't that 25?
Yes.
Yes. And then they'll say, well, the square root of 9 is 3 and the square root of 16 is 4. So there you go. There's your 7, Jeff. Now, where did I make a mistake?
it should be times under the square root.
I understand what you mean, but so the mistake I've made is that square roots do not play with addition well. I really want you guys to get this. What do you guys, what's another way to write the square root of something? Do you guys know? X to a power, right? How do I rewrite square root of X?
1/2.
Yes. So they are powers. What are powers based on? What's the operation that powers are based on?
Multiplication.
Beautiful. So like what I think Tang, what you just said was if I had the square root of 9 times 16, that would be 3 times 4, that's 12, and that's beautiful. Not a damn thing wrong with that because square roots are powers. They play well with multiplication, no problem. And you already know this shit, well, hopefully. You guys still make a mistake with what I'm about to put up here, but what is this? Is that this?
No.
Hell no, because powers do not play well with addition. You can't distribute a power across addition because powers are not defined based on addition. I really want you guys to be with me here. In fact, let me push this a little bit more. What is stay with me just for a second. Stay with me just for a minute. Well, stay with me for the whole damn time. Let me be careful. Isn't 4x x plus x plus x plus x? Right? So isn't a coefficient based on addition, which is why that plays well together? See how the 4 can just go wee? Easy, because this is based on addition. That is addition. This is based on multiplication. That's not multiplication. Oh, shit. And radicals are powers. So right now, make this a monster huge bullet point because this is in so many math courses, this one and every one after this. You can never tell me that this equals this. No, 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 nope, no. So don't. Stop doing it right now. Right? I want it to physically, it hurt me a little bit to write that until I could say not equal to, then I felt better. Right? Got a little sick. I was like, okay, maybe. I understand brain farts or like momentary optimism, or that sounds so bleak. Momentary optimism, but like in the moment. You're like, oh, cool, that's easy. And then this happens. I mean, I make those kind of mistakes where I'm like, oh, if that's true, then I see what to do. So my brain says, sure, it's true. Let's go for it. And you got to go, no, brain, I'm sorry, buddy. It's not that easy. And like, oh, shit. Maybe you guys with me at all? I've seen this kind of thing on many papers, and I need to stop it now. I need to stop it now. Okay, maybe. What was the other thing? What was the question? Well, let's see. Let me do this real quick. 3-1. I got a question in chat. 3-1, number 75. Where are you? There you are. Oh, yeah. Okay. This one is what I call, it's just a brute force problem. Does it make sense if I say that? I mean, this one is just, it's not even as bad as it looks at first. In fact, let me give it a more technical name. This is one I call a construction problem. I construct what I need. So what do I need for number 75? I need to know what this is so I can subtract, and then I need to know what this is. All right, let me go figure out what that is. And then I can put them in with a minus in the middle. That'll make your problem so much easier than some of you guys are making it. So let me do f of 7/3 by itself, its own problem, right? Are you guys? Oh, you can't really see the board. You guys can say that. I love you guys. You got to tell me when I do that. I think I've been doing that. Oh, shit. F of 7/3, figure out what that is, put that number there. H of -2, figure out what that is, put that number there, and then go ahead and subtract them. Does that help with that one? Hello? Are you out there? Does possibly do step by step? Well, sure. Let me do a different problem. All right. I'm not going to do your homework for you. I have to grade it. I already have enough work. So let's say f of x is 4x minus 2. And let's say g of x is, what kind of things do they have up here? Sure. 3x squared minus 7x. And I want to know what f of 7/4 minus g of -2. So let me figure out what's f of 7/4. Well, that would just be 4 times 7/4 minus 2. That will be 7 minus 2. That's 5. What is g of -2? That would just be 3 times -2 squared minus 7 times -2, which is 12 plus 14. I think it's 26 maybe. So I get 5 and I get 26. So now I can do this. That would equal 5 minus 26. Is that cool? So that's what I mean by construct. This is the problem they want me to do. I don't know this. Let me figure it out. I don't know this. Let me figure it out. Now I know one. Let me just subtract them. Right? Construct what you need to answer the question they give. That's, you see that kind of thing also on this kind of problem? Construct this, throw it in there. Right? Or you see the one with the x plus h? You got to construct it first, and then you can throw it in there. Does that make sense? I don't know why I keep getting that. All right. Just be really careful. If you separate the work out, you won't make as many mistakes. If you try to do it all at once, there's so many little mistakes you can make, especially with the not minus in the middle. Okay. Anything else, guys, before I jump back into... All right, let me see. Here's the next thing on my notes.
We're on chapter 4, right?
Sorry?
We're on chapter 4, right?
Yeah, we're in 4. Right now we're talking about 3, some leftover stuff from 3.
Okay.
Okay. So here's another thing. The piecewise functions, understandably, are still a little bit freaky for us. Why are you such a bad marker? I don't know. Are you better? Yeah. So what if I give you, let's see. There are problems in the book that look like this. All right, and then they say, what is f of 0? And I have way too many people that are putting 0 in each one of these and giving me multiple answers. No, how could the, in order to be a function, when I plug a 0 in, how many answers can I get out? At most 1, right? So if you get multiple answers for a single input, that's not even a function. So the whole problem just goes to shit. So which thing am I going to use for this? Well, my input, which one of these does my input meet? These are the requirements to use these.
The middle one?
Yeah, 0 is in between, so I got to use this one. Yay. So what if I say, what's f of 3?
The bottom.
Yeah, the bottom one, because this one can't be 3, but this one can be 3, so I have to use this one now. -3 minus 2 is -5. Okay. You guys see what I'm saying? There's at least one problem like that, if not 2 or 3, man, I can't remember now. And so they're more specific than just graphing them. I think more of you guys get the graphing part now. You're a little bit more comfortable graphing piecewise functions. But for some reason, this problem really threw us for a loop. You just use the part that's allowed to be used for the input that you're given. Okay, maybe. All right. And then I think I already said something about this. If the problem you are working with is a problem that requires a graph from you, and your answer looks like this, and that's it. All right, that's complete shit. I need to be very clear with you, right? It's not this class. It's another class for somebody who doesn't like it when I cuss. And I'm like, man, you're gonna have a rough semester. This is bad. This is bad. There's no tick marks, no scale, there's no work, there's nothing. And then what the hell's going on there? So do you guys see what I'm saying? So I need some work, I need some scale. The whole point of this class, one huge point, is graphing, right? So we're going to be doing a decent amount of graphing by hand. We're also going to do some graphing in the calculator or on Desmos, whichever one you like better. So I do want to talk about something with graphing when finding maxes and mins. Does that sound familiar to any of you guys? Have you guys gotten up to that part of the homework? So I want to show you how the calculator can find those more specifically, right? And then I got to talk about symmetry a little bit, and then we're going to finish up chapter 4. That's the plan. Let's see if I can do that. All right, so let me pull up the calculator real quick. We'll look at it on Desmos too. Desmos, of course, just kicks too much ass. Let me see. There you are. Okay. Just gotta wait for it to wake up. There he is. There's, all right, here we go. So let me show you this. So here's some freaky, oh well, this is something we were using before. Let's see what happens if I just make up a function. Let's see, so if I do 5x cubed minus, oh, gather, over minus 6x squared plus 8x plus 3. Okay, let's see what that looks like. It should look okay. I'm gonna hit zoom. I'm gonna hit zoom 6 to give me a standard window. Okay, good. That's probably not gonna do what I want it to do, is it? Let me see if I can make something better. Would this make it better, Jeff? I don't know. Let's see what that does. Yeah, sweet. All right, that's all I needed to do. All right, so let's make it 5x cubed plus 6x squared. Good Lord. Sorry. Let me try to get, so I can speak better. That's going to help. All right, 5x cubed plus 6x squared minus 8x plus 3. If you're playing along at home. Hit zoom 6 and it looks like this. Now, what can I not see, but you can tell is there? Like, what's this? I can see this. What would I call this?
The local minimum.
Local minimum, very cool. What is there obviously also there that I can't currently see?
The local max.
It looks like it's got to be a max here. It's got to turn around so it can come back down. So do you guys remember how to look up further? I want to control this and make it bigger. So which button do I want to press?
The zoom.
The window.
Window. I want to get more direct control. Let me make my Y max. I want to make my Y piece larger so I can see up higher. So let me just make it 20 just to be sure. Well, let's see if I'm sure. Yeah, there we go. Now, here's the cool thing. So you have problems in the homework. They give you this big ass ugly looking thing like what I just put in my calculator. I don't need you to graph it by hand. Good Lord. That's going to be the next section where we learn how to graph some certain things by hand a little bit better. You can totally graph it in the calculator. How do I find that maximum? I could trace it, right? If I trace it, I can kind of get a feel for what that is. But how do I figure out exactly what it is? Well, I'm going to show you. So anytime you want to calculate something graphically, do you guys agree? That's what I want to do. I want to calculate the local max graphically. So everything up here is all about graphically doing something. So see how it says calc right up there? So I'm going to hit second, trace. I can't remember if we've been in here yet. Let me just show you what some of these things do. Value does exactly what it sounds like. If I plug in 2, it'll tell me the value for an input of 2, the output is 51. Woohoo! 0 does exactly what it sounds like. All right, now stay with me. This is being recorded also. What does a 0 of a function mean? Does anyone know another name for the 0 of a function?
The x's?
What about the x's? Be more specific.
Is it like where the line, where the graph meets the x's?
Means the x-axis, so the x-intercepts. So another name for the zeros of a function is the x-intercepts. Now watch this. Watch this shit, kids. All right, where I'm at. So there's my thing. Look what it's asking. It's going to ask me 3 questions. What is your quest? No, it's going to ask me, it wants a left bound. So can you see where the answer is? Isn't the answer about right there? That's about the x-intercept. That's as close as I can get. So I'm going to hit the left button at least once, hit enter. I'm going to get right back on top and hit the right button a couple times, enter. So now it's going to search in between those 2, and then I'm going to put the cursor as close as I can to the answer, enter. So now I know what the x-intercept is. And look at this. What does this mean? So much shit coming at you. I love it. What does this mean? What the hell is this? Does this mean my calculator needs new batteries? I hope not, because it's an emulator on my laptop. It's got full battery. So does anyone know what this E means?
Is it like when it goes on forever?
No, not forever. E is in place of, oh, I got a chat. Let me see if you got it. Yes, scientific notation. So E is in place of times 10 to the. So 1 times 10 to the negative 12. So that's basically saying 0. But the calculator, the algorithm it uses to find the x-intercept in this case, kind of gave up when it got this close. I don't know if you guys are with me. What's interesting is it's got a built-in tolerance for when to stop the algorithm. And sometimes it'll say something here that's not 0. Is everybody good so far? So if the calculator ever spits out at you 7e negative 2, okay, that's 7 times 10 to the negative 2. I mean, it's just scientific notation. Okay. Now, what I really want to find is the maximum, and you can do the same thing we're going to do for the minimum. So if I do second trace, get to calc again, you can see min and max. Let me do maximum. And it's going to ask me this, it's going to ask me the same 3 questions. Go to the left of the answer, go to the right of the answer, and then give me a good, oh shit and a half. Jeff, let me try that again. Dadgummit. Number 4. All right, here we go. Go to the left of the answer, go to the right of the answer, and then give me a guess for the answer. Enter. There you go. Now there's the maximum. That's where the maximum happens, and that's what the maximum value is. I love it. So when they ask you for the local max and min in the book, they normally go ahead and mean the whole point. So the local maximum for this is going to be the point negative 1.23, comma 12.61. Rounding it off a little bit. So can somebody tell me what's the first interval that this thing is increasing on? What's it doing forever here?
Negative infinity.
Yeah, negative infinity. And where does it stop increasing?
Negative 1.2.
Kick ass. Sorry. Because where things are happening are answered with X values. What is happening there is answered with Y values. So when you're telling me the intervals where it's increasing, decreasing, it's going to be all about the X. So from negative infinity to negative 1.23 roughly, that's where it's increasing first. And then it starts to decrease. And if you can figure out the minimum, how do you do that? The same way we just figure out the maximum, except now you pick minimum. It's going to ask you for the left bound, right bound. Is everybody cool with that so far? You guys are out there? Now, just to show you, nobody's saying they're not cool with that. So let me show you what Desmos looks like. Desmos, of course, kicks ass. All right, let me see where I put, there you are. Okay. Let me bring you guys back into this. Desmos. Oh, it would have been smart for me to remember what the hell it was I put in there. Hold on. Ah, doesn't matter, Jeff. Was it 5x cubed, I think, right? 5x cubed plus 6x squared minus 8x plus, I can't remember, 3, I think. So look what it automatically, this is so kick-ass, it automatically calculates the standard important points. Do you guys see what I'm saying? There's no separate algorithm to run. It just does it for any function. It automatically calculates the turning points. It calculates the intercepts. It's kind of insane. It's kind of beautiful. So I think that's what we got just a minute ago. I love it. And we didn't get that one, but there it is. Woohoo! So if you know the turning points, you can build the interval. So where is it decreasing? From what to what is it decreasing?
Negative 1.3 to 0.4.
Yeah, negative 1.23 to about 4.43. I love it. Where is it increasing, decreasing? X values. What are the maximum values or something? What is happening there? That's Y values. I understand when you're looking at this thing, our brains look along every, no, it's all about the X. It doesn't really matter how high up or whatever it goes. I just care about the X things, about where these things are happening. Okay, maybe. Okay. And the last thing I need to talk about from chapter 3 was symmetry. There's a lot more symmetries than these two, but these are the two main ones, even and odd symmetry. Okay. And the easiest way to remember these, it's too awesome. And just, we are going to learn more symmetries later this semester. But we'll start with these two. So we have even symmetry and odd symmetry. Even symmetry says this. If I put a negative X into my function.
Is not.
Sorry?
Perfect.
Jordan, I think your Wi-Fi is a little bit spotty, buddy. You're like, wow, 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 wow. Okay, but I think you're just telling me to pick this up, right? Is that all right? Okay. So an even function is when you put a negative value in, you get the same thing as if you put the positive value in. Odd function is if I put a negative value in, I get the negative, of what I would have gotten. So let me make this a little clearer. The most basic even function is x squared. And the most basic odd function is x cubed. Isn't that crazy? What do I get when I put a negative x in? Right? When I put a negative x in, what happens here?
X squared.
Sure. What do I get?
Positive.
Positive x squared, which is the original function, right? Is everybody with me? So if I'm given a function that's not x squared, how do I test it? I do this. If I put a negative x in and I get the same function at the end, that's even. What happens here if I put a negative x in? What's negative x cubed? What's the negative cubed?
Is a negative, right?
Negative and x cubed, yeah. Which is the negative of the original function. So that's the technical test for even and odd. But let's look at the visual of these. Even symmetry means, holy shit, Jeff. All right, wait a minute. All right, even symmetry means we need someone who can draw better. Even symmetry means, that's a little bit better. The mirror would be the y-axis. And you remember that because the most basic even power looks like this, which is a mirror image around the y-axis. This one's going to be freaky. This one is a new idea. This is symmetry through a point, through the origin. So every point that's here, if I draw through the origin, I can find its mirror image point over there. That's neat. So when I put like a 2 in, I get an 8 out. What do I get when I put a negative 2 in? I get a negative 8 out. So this is really strange. This is called origin symmetry. It's symmetric through a point. So if I saw a function like this, I would have to prove it, but what kind of symmetry does it look like it has? Shit and a half, Jeff.
Even.
Even symmetry would mean if I put a mirror here, so I should be able to see this image here and I don't. Do you see that? So that is not even. That is going to be odd symmetry because it's through the origin symmetry. Even symmetry would be, if I just shift that over a little bit, and I make what I affectionately call the octopus graph. Right. I don't know if you guys know what these graphs are. These are graphs we're going to study later this semester. These are trigonometric graphs, right? This is the cosine graph, and that's the sine graph. Good old oscilloscopes and stuff in the background of horror movies and stuff. Okay. So that would be even symmetry because I can see this guy's mirror image is through the y-axis. This guy's mirror image is through the origin. Everywhere I look, if I go through the origin, I see the mirror image on the other side, like that. That's really weird. We're not used to point reflections through a point. That's neat. But you can, hopefully you can see what that means. If I go through that point, I see its symmetry. If I go through the y-axis straight across on an even graph, I see its reflection everywhere. Okay, maybe. So if a problem gives you a function, you do it this way. If a problem gives you a graph, you do it this way. Go ahead, sorry.
Aren't the sine and cosine graphs just circles rolled?
That's how you create them.
How does that interpret with this though?
If you're rolling a circle and you're keeping track of something on the circle, this would be over time, like if you have a penny stuck to the circle and you let it roll, this would be what the penny kind of sees as it goes. And it's like, oh, I'm up top, now I'm on the bottom, now I'm up top, now I'm on the bottom. So it's sort of like letting that roll forever. Anyway, that's a very quick thing. When we get to trigonometry, I have a ton of animations to show you, including what you're talking about, Jordan, because there's a lot of kick-ass animations that go along with the idea of what trig is trying to say. All right, I like it. So that's for later. Okay. All right, so that was all that was left that I remember from chapter 3 that I either saw issues with in the homework, or this is I just forgot to talk about even in odd symmetry, right? I was grading the homework and I'm like, oh shit, I never talked about that. Okay, let me leave it up there. So we're gonna get into section 4.2. My hope is that most of you guys will appreciate the hell out of chapter 4. It's supposed to be simple. It really is just mx plus b, that kind of stuff. That's all it really is. 4.2 is a little bit harder, but not that much. Let's see. Let me move you guys over there. Where did I put the book? There you are. Okay. I have a problem here I want to go over with you guys. We'll find it together. Let me see. Here it is. Perfect. I love it. All right. So the first thing I'm going to do is just say, do that problem now. I'll wait. And then we'll do it together. So this example one right here about this town's population. See how far you guys can make it with this. Remind you guys about a couple things here. You could use this, or you could use this. Oh, neither. All right, sorry. I'm discovering new things about my pen, what I can do. Okay. So let me ask you guys, what's the first thing any of you are doing out there?
Finding the slope.
Good, I love it. It's perfect, because I got to know the slope and I've got to know a point. I have no idea why that decided to make that. Anyway, okay. So what points are you using?
$2,004 and $6,200.
All right. And then of course, 2009, comma, 8,100. Did anyone use different points? All right, so I'll do it this way and then I'll show you a better way. Yeah, so what do you get for the slope then if you do this? Looks to be 900 divided by 5, is that right? So that's 180.
I thought it was 1900 divided by 5.
Oh, that would be better, Jeff. So then it's 380. Okay, thank you. And then what else can you do from there? What did somebody do from there to get the equation? Oh, to be honest, the question doesn't really ask for it, but there will be questions that will ask for it. This is the average rate of change. That's what the slope is. How can I get the equation of the linear model? So I could use this equation, y minus the y piece of either point equals m times x minus the x piece. Let me see what you guys are talking about. Point slope, exactly, I love it. This is point slope. That looks really gross, huh? Yeah, I agree. That's why I wouldn't do it this way, but I'll show you how I would do it. So, I mean, you got calculators, who cares? You can do this in your calculator. So 380x, oh, I have no idea. Minus whatever 380 times 2009 plus 8100, whatever the hell that is. Are you guys okay out there? You could use either point you want to, right? So I get this. Is that all right? You guys all right out there? Anybody? Okay, all right. And now you can answer any question they want to. So what will it be in 2013? Well, now you just plug a 2013 in. Minus this big ass number.
Is it okay if it's negative?
No, let's see what happens. I don't get negative, I get 9,620, which seems to be on track, right? 6,200, 8,100, 9,620. Do you see what happened, Jordan? So it'd be 380 times 2013 minus 755,320. And you should get 9,620. Now let me do this because I hate this. Let me show you something much better. All right. There's nothing wrong with this. It's just grosser than it has to be. So the slope doesn't change. I could have left that there. I'm going to back up a little bit. So look at the points I'm going to use. All right. So this is, you got to be careful when you're able to do this and when you can't. So I'm going to identify, I'm going to say my variable is years after 2004. So my first point is 0, 6,200. And my next point is 5. No, Jeff. Boop. 5, 8,100. Are you guys with me out there? We much rather use not a full year in an equation. So we're creating the equation. It will do what we want it to. So I want it to use years after 2004. Okay, if I create it that way, that's exactly what it's going to use. The slope actually stays the same. You guys see that? Because of course the difference between 5 and 0 is the same as the difference between 2009 and 2004 is the same thing. All right. But now when I go to construct my equation, it's going to be a little bit better. So what's nice about this one is it's the y-intercept. So now I can just do 380x plus 6200. Now, why is this different from the other number we got earlier? Because now x is not a full year. So what would I put in for 2013? What would x be for 2013?
$13.
No, careful.
9.
Oh,
9, yeah. Yeah, be really careful. Yeah, and you've already seen that in a few problems, I believe, by the time you get up to here. So to do part A, I would do y equals 380 times 9 plus 6200. And you'll get the exact same answer we just got earlier, which was 9620. Let's see if that's true, Jeff. Let's see, buddy. Let's see, math boy. Yay. As I was plugging that in, I'm like, damn it, please tell me I didn't make a mistake before. All right. How do I do part B now that I've got an easier function to look at? How do I do part B? Part A, I plugged an x value in that corresponded to this year because x is related to years.
You plug it into the y value.
Yeah, I love it. I want the population, which is what y is all about, to be 15,000. So then I have to solve this equation for x to see what year I'm in. What year is it? Jumanji. And then, yeah, so now you just got to solve that little equation. Who cares? I almost don't care anymore. The interestingness is gone. You will see problems pretty much exactly like this in the homework about population growth. Now, we should know population growth is not normally linear, but you could estimate it to be linear for certain time ranges, but yeah, normally it's not linear. All right, I'm going to clear all that away. Let me see, clear this away. You guys ready? All right, I'm curious which way they did it. Let's see which way they did it. Oh yeah, they did it. Yay, good way to go, book. Way to go, book. Look, all that stuff looks familiar. Oh, we didn't actually do this, but there you go. All right. So look at this guy. What do you guys, now this is a different type of problem, but this is nice. This problem is even nicer than the one we just did. Can you guys see why? Can somebody tell me the slope of my function? So now I've got the cost is C. So in mx plus b, do you guys see why this is very often called the fixed amount? Because as x changes, b don't give a shit, right? It just stays b. As x changes, this part changes, of course. So what piece of this information that they give me that is just the slope? I don't even have to calculate. They told me the slope. If x is the number of donuts, how much will the cost change per donut?
1/4.
Yeah, of course. So this will be 0.25 per donut plus my overhead. My fixed costs are $25,000. So later in this class, we're not going to do a ton of business because I am not a business person at all. Can I do business? Sure. I know the math of the business and bullshit. I hate it though. It's really, but we will talk a little bit about cost and revenue and profit and stuff. And if you go to calculus, you get even deeper into it. Okay, anyway. So that's part A. We got a linear function, and this was so much easier. I didn't have to calculate the slope. They just told it to me. And now what is this? And this is silly. This is dumb. I'm sorry. They told you what the y-intercept is, didn't they? right here. Anyway, so you got to love if they ask you this, you're like, well, let me just regurgitate what you just told me and they'll be done with the problem. So that problem was too easy. I don't know if you guys agree with me, but this idea of this is 25 cents per donut. That's a big giveaway that is more than likely the slope, because that is the rate of change of cost in this case. How are you guys doing out there? Some of you guys, I don't know if some of you guys are thinking to yourself, how do you make lines difficult? Well, this isn't really hard, but it's not just straight up plotting points. It's definitely a little bit more than that. All right, let me clear this away. It reminds me of when I taught astronomy and people were like, what are you doing? This class is hard. I'm like, did you think it wasn't supposed to be hard? Anyway, let me see. Do I want to do this? No, I don't care about this. All right, that's enough, I think. What do you guys think? Is that enough for today? We're right on track. We just finished up chapter 4. Several of you are almost done with chapter 3, which is awesome. And then some of you guys I'm a little worried about where exactly you are with homework. It's okay to turn it in late. It's not going to kill you. I say late homework only hurts you if it's really, really late or if you turn a lot of stuff in late. But you just let me know if you're having a lot of trouble keeping up. Otherwise, turn it in so I can take a look at it, right? Cool. And let me know if you need to hang out. Otherwise, I think we're done for today. I think that's plenty. What do you guys think? He was like, dude, I was done 30 minutes ago. All right. Well, thanks for hanging out for a little bit longer. Let me know if you need to hang out after class. Thursday, I've got extra office hours. So Tuesdays and Thursdays now, extra office hours if you want to come.
I have a question, Professor.
Yes. Yes.
So can you go back to the question again, please?
Hold on. Which
The
question?
last question.
You too, Austin. Hold on.
The
Let me
donut.
pull it back.
Yeah.
Hold on. Oh, shit. Now I made it go away. The one with the donuts?
Yes.
Okay.
So what? I just don't understand the sentence. What is a fixed cost?
Oh, fixed cost just means it doesn't change over time. It doesn't change because you make more donuts. So rent, insurance, and other expenses like water and heat and all that kind of stuff. Well, you could argue that it would change, but this would be the total fixed costs. So these do not change because I make more donuts.
Oh, so
If I rent a building, it's not going to suddenly go. The rent's not going to go up because I made 5 more donuts, right? So that's what they mean by fixed cost. If it's fixed is another way of saying
unchangeable or something?
Doesn't change.
Yeah.
It really fixed is it means it doesn't change.
Okay, so
yeah,
that's like so we are counting a profit in this case?
No profit in this problem. It's all about cost. So that's why we added the cost of donuts.
Oh, okay. Yeah, now I got it.
Yeah. So I'm sorry. I did say later we're going to bring in revenue, talk about profit, but this problem was only about cost. Yeah.
Okay. Yeah.
Okay.
Right. Thank you.
You're welcome.
Have a good one.
Everybody else, you're good?
Yeah.
Excuse me?
Yes.
I don't know if you got my email, but I sent you the email regarding my makeup quiz. I don't know, have you decided to give it to me?
Let me see. Oh, there it is. Okay. I don't know why I forgot to go back to this. Oh yeah, because of that's right. Let me think. All right, so let me do this. I'm going to pin this up here so I don't forget. And as soon as I get that created, I'll let you know. Okay?
Okay, thank you.
Sure. I'm sorry about that.
It's fine.
I didn't put a little note on it to go back to it. How's everybody else? All right, guys. I don't see any questions. I'm gonna head out. Uh-oh, Connor? Faye, what's up?
Yeah, I had a question. Where's the like due date and homeworks? Is it just on the homework page?
Yeah, I'm not sure. Let's see which way you're looking at things, but let me show you real quick.
Okay.
You can get it in several places. So like when you first log in, you'll see, let me become a student here. You'll see underneath to do, see all these?
Yeah.
Good. And then if you look under modules, when you go to the turn this in here, like turn in
yeah.
chapter here, you'll see all the due dates.
Yeah, that's what I was looking at. Because like when you go to the homework page, it has like dates like February
Now,
1st to
again,
the 10th.
like I've said
I don't know what that
before,
was for. That was like when we go over it, I'm guessing, in
yeah,
class.
that's the dates that will be in those chapters. Yeah.
Okay.
These
Yeah, that
years.
was my question. Okay.
Okay.
Thank
Cool.
you.
Sure. Everybody else okay? What's up?
I do have one more question.
Yes.
Regarding 42 and 3.7.
Let's see, 3, 7, 42.
My main question is my slope looks a little funky. I ended up getting like f of inverse x is 3 over x plus 2.
No, let me see. Wait a minute. If I was more awake, I could figure out what that was, but let me see. Maybe it is.
I could
Hold on.
show you the problem that I did.
See, x, y minus 2x, 3x. What? Well, yeah. All right, that looks more like what it should be. 0, you get 3, 3, you get, wait. Maybe that's not it. Maybe I shouldn't try to do it so quickly. Yeah, that should be it. 2x plus 3 over x. So if x is 1, it's 6. And if x is 6, what the hell am I doing wrong? Anyway, what'd you get again? Sorry.
I don't know if you'll be able to see this if I hold it up.
Oh yeah, it's gonna be, yeah, it's gonna be
like something funky like that. I got 3 over x plus 2. I don't know if you
I
can see that.
see. Oh.
I did some.
Oh yeah, that's what I got. I just
don't know
didn't do
where I
that.
messed up.
It looks
So this
about
is
correct. It looks about correct. It's going to be really difficult. You know, you have to do it by hand. So it's you might not have the curvature correct, but this one's a little weird
Sure.
because it's already almost its own inverse. So it sort of almost wants to overlap itself, right?
So I just want to make sure I wrote it right. I wrote 3 over x and then separately next to that plus 2.
Yeah, that's what I got.
Is that the right way to write that?
Well, the way I wrote it actually is 2x plus 3 over x. So I just made, I didn't even do what I was about to say, but so what I did was that.
Okay.
It's a little bit
2x
out of
plus 3
focus,
over x.
which is the same thing as yours, right? If you split that up, it'll be 2x over x plus 3 over x, which is 2 plus 3 over x. It's the same thing.
Oh, okay.
Yeah, but so it doesn't really change anything. So that's the correct inverse. It's just when you graph it by hand, it's not going to be as immediately obvious that it does reflect correctly.
Okay.
Yeah.
And then in the future, it's okay to have that weird looking slope where it's 3 over x.
No.
Oh,
This
because
is
this is a 1
not linear.
over x.
Not linear
Yeah,
at all.
yeah. Okay.
So yeah, calculus is where you talk about the slope of this function because it's changing at every point. So we don't know
Okay,
what the hell this
cool.
is. Yeah.
Thank you.
Cool. You're welcome.
Have a good night.
You too. Faye and Charles, you guys okay? Hello? Oh,
I
Faye,
have
what's up?
some homework questions for section 3.5. I think I'm just having some trouble understanding like how to tell it's like a vertical stretch or like a horizontal stretch or when it's
Which
compressed.
one? Okay.
Like for example, like 56, 59, 62, like all of those. Like the 6F is like on the outside and then it's like on the inside.
Oh. Yeah, so okay. Whenever it's on the outside. All right. So like let me give you an easier example. Like, all right, like here. See that's on the outside, the +1.
Yes.
So that's going to affect the up and down direction. It's going to be a vertical shift. It's going to go up 1, right?
Mhm.
If it's with the X, if it's in with the X, that's going to affect left and right. That would be a horizontal movement. So look at the problem number 56. The number is outside. So that's going to be a vertical change. So in fact, what does it say? It says that G is 6 times f of x. So it's going to be a stretch. G is going to be f stretched because it's going to be 6 times as big.
Oh, okay. So
if it's
then,
inside, like 57, that means it's going to compress it because when it's inside, it does the opposite of what it looks like. So it'll be 1/5 as big of the x's that get compressed. So if it's inside, it's left and right. If it's outside, it's up and down.
got it. Okay.
Yes. And if it's inside, it's the opposite of, like the +3 means it goes back 3, that kind of thing. It's the opposite of what it looks like. Yeah.
So what about like 59?
Well, is it inside or outside?
It's inside. So
Inside. So it's going to do the opposite of what it looks like. So it's not going to make it 1/3. It's going to make it 3 times as big. And it's inside with the X variable, and the X variable is left and right. So it's going to make it 3 times as big horizontally. It's going to stretch it this way.
because it's inside,
Because it's inside.
that one's going to be a stretch.
Because it's the opposite of 1/3. It actually triples it. And think about it. All my X values have to be 3 times as big as they had to before somebody put that 1/3 there.
Oh, okay. So before, okay.
Yeah. So if it's a spring, like if it's a oscillating thing, that actually, to me, that's where it makes the most sense. If it's oscillating, it's just going to pull it, and they're going to be longer oscillations, sort of like a slinky.
Okay, that makes sense.
So yeah, a lot of functions, the compressions and stuff doesn't make sense because it's not enough of it to see. But if you have a oscillating function, it does look like a spring. Compression, it makes it tighter, and stretch makes it like, I think about my slinky that I broke when I was 7. Just pulled it. Oh no. Sorry.
All right, that makes a little bit more sense. I was just getting confused on that fact.
Yes, understandable.
All right, perfect. That's it for me. Thank you.
All right. See you.
See you. Thank you.
Sure. And Charles, do you have questions, or are you just listening?
I have a question. Well, not so much questions now that I'm looking at what I originally submitted. Because 3.2, you look like your pin blew up on my paper.
Oh, let me see. 3.2. So what was going on there?
Knows. I see I made a lot of silly mistakes. -18 + 3 is not +15.
Well, let me see where to go. Here we go. Yeah, okay. So some of it was just showing me work. Some of it, like number 15, the whole point with number 15 is you do not want to include -1/2. So they should be parentheses on the 1/2. And it should be a -1/2, right?
Yeah.
Yeah. Same thing with number 18. You don't want to include those. Number 21 is a little bit more difficult because not only is it on the bottom, it's also under a square root. So it's sort of like both restrictions at once.
Okay.
Number 24 is easy, believe it or
Yeah,
not.
I don't know why I didn't put 1 across the line.
No. What's on the bottom?
It's X, right?
X. And what can the bottom not be?
X. So 0.
No, what can the bottom not be in general?
Oh, negative X.
No. What can you not have? What can you not divide by? What number?
0.
0. So therefore, X cannot be 0. You are right. It is 1 everywhere except 0. 0 divided by 0 is not even undefined. It's called indeterminate. It's a neat thing. 0 divided by anything is 0. Anything divided by 0 is undefined. So what is 0 divided by 0? You got these competing things, and it's freaky. So X can't be 0. Yeah.
Okay.
And yeah, let me know if you have any questions on any specific. I see like your piecewise. Just pay attention, like on number 39, you know they're both linear, so neither one of them should have any curve to them, right? And I think like, I'm not sure what happened on 42. Oh, it still had a curve to it. It should be a line for that one. The bottom one, the one's a parabola, the other one's a straight line. And then 45, you just didn't show enough. You know, it keeps going. You got to put some negative X values in for the absolute value, right?
Okay.
Okay.
Yeah.
So yeah, let me know if anything on there, you're not sure what to do. Otherwise, you got time for corrections.
Okay.
They're not due till the final, so
yeah,
do them
I
whenever
gotta-
you got time.
Gotta knock out this one, but I do have a tutor, and so that's why you'll see some homework will pass. Not a problem, and then you'll have the assignments that I turn in by myself and
Gotcha. Well, now you got some very targeted questions for your tutor. I like it.
Although, when we were looking at the parabolas, right?
Yes.
When they were on 0, or when the vertex would hit 0, when I would zoom in, it would like cross the dotted lines a few times, right? So if you zoom in on the grid on the book, one grid line has 3 dots, and the line kind of crosses, or it stays on that line for a little bit. So I asked my tutor, I mean, technically, if you zoom in close enough, it wouldn't pass the vertical or horizontal line test.
It does, but it depends on the resolution of the graphing tool you're using.
Okay.
Because at some point, it's moving down by the tiniest steps. It is always moving down, and then it's at 0, and then it's always moving up, but it's such small steps around 0. It's sort of like the curvature of the Earth. And if you zoom in enough, it looks like a flat line. But we know it's always curving just so slightly that us crazy little humans, some of us still think it's flat. Holy shit. But anyway.
Okay.
Yeah.
Well, I appreciate you going through my garbage. I'll do tonight's, get the corrections. Thank you.
No problem, man. I'll see you tomorrow.
Yes.
Okay.